Let's solve a problem involving a bowling ball and sound waves. A bowling ball is released and travels with constant speed down a 16.5-meter long lane. The bowler hears the sound of the ball hitting the pins 2.5 seconds after releasing the ball. If we know that the speed of sound is 340 meters per second, what was the speed of the bowling ball? Let's visualize what's happening. Here's our bowling lane, which is 16.5 meters long. Here's our bowler, and here's the bowling ball being released. And at the end of the lane, we have the pins. Let's break down what happens in this problem. First, the ball travels down the lane at a constant speed that we're trying to find. When it hits the pins, a sound wave is created that travels back to the bowler at 340 meters per second. Let's identify the key components of this problem. We know the total time from release to hearing the sound is 2.5 seconds. This total time consists of two parts: the time it takes the ball to reach the pins, plus the time it takes for the sound to travel back. Let's first find how long it takes the sound to travel back. We can use the formula: time equals distance divided by speed. The sound travels 16.5 meters at 340 meters per second. This gives us 0.0485 seconds for the sound to return. Now, we can find how long it took the ball to reach the pins. The time for the ball equals the total time minus the time for sound. 2.5 minus 0.0485 equals 2.4515 seconds. Finally, we can calculate the speed of the bowling ball. Speed equals distance divided by time. The ball travels 16.5 meters in 2.4515 seconds. This gives us a speed of 6.73 meters per second.